Okay, let's do question number 4 of 6.3. Let's read the question first. If QR by QS equal to QT by PR, so QR, let's see where is QR. QR is here by QS, QS is here, QT is here, PR is here. So it's like QR by QS, PT by QR. So if it was this by this and this by this, it would have been easy because this, but then unfortunately it's like this, and this. Now what they've given us is angle 1 equal to angle 2. Angle 1 is equal to angle 2. So let's make use of this information that they gave us. Angle 1 equal to angle 2. Let's just draw the triangle where angle 1 and angle 2 is there. Okay, so it's P Q R, right? This angle 1, this angle 2. 1 is this, 2 is this, so PQR. So if angle 1 and angle 2 is equal, what kind of triangle will APQR become? It will become an isosceles triangle. And in isosceles triangle, what? Not only the two side angles are equal, but the two sides will also be equal, which solves our problem, right? So given angle 1 equal to angle 2, therefore triangle PQR is isosceles. So if it's isosceles, then we know that therefore PQ will be equal to PR. So we have already solved the problem. See, instead of PR we can put PQ. Now it will become this by this and this by this, right? Easy. Again, QR by QS equal to QT by PR, which is given, right? Or let's make this equation 1. So QR by QS equal to QT by, instead of PR I'm going to put PQ. Now we have PQR by QT equal to QS by PQ. So this by this equal to shorter one by shorter one, right? So the ratio is the same for this triangle. See, the red parts are supposed to be done as rough section. So we're taking triangle this PSQ, and then we're taking the big triangle, which is QTR. It's too noisy. So PQS TQR. Huh? We're taking these two triangles, and then we just proved that QR, which is this side, by QS, which is this side, equal to QT, which is this side, by PQ, which is this side. So this and this are ratio. So what do we need? This angle for what? SAS, right? Two sides are ratio, and the angle between them is equal. Then we can say that by SAS rule, these two triangles are similar. But angle Q and angle Q, we're talking about the same angle. Angle QI here, QI. So if this 45, here will also be 45. And this right from 1, okay? Angle Q equal to angle Q. Therefore, triangle PQS is similar to triangle TQR by SAS similarity. Done. Got it? So first thing, we take what is, see, whenever in geometry, okay, especially, they don't usually just give you the values randomly. Like if this is equal to this and this is this, they just don't give it like that. It has a purpose for everything. So make sure you look at what is given, and then from there try to solve the solution. Okay, let's do question 5. S and T are points on sides PR and QR of triangle PQR. So in this question, they did not give us the diagram, so we'll have to draw the diagram. Okay, so let's draw any triangle PQR. Any triangle, okay? Any triangle PQR. So S is a side on PR. So where's PR? PR. S is a side on PR, and T is a side on QR. QR is here. Let's just join these two. S and T are sides on PR and QR of triangle PQR such that angle P is this one, is equal to angle RTS. RTS is this one. So this angle and this angle, they're saying it's equal. Show that triangle RPQ is similar to RTS. So what we're going to do is, I'm going to, since these two angles are same, I'm going to draw a rough figure here. You can do this in your rough section. The smaller triangle, the bigger triangle. I'll write this one as it is, the bigger one. Doesn't matter which one you write as it is, but for this case, I'm just writing the bigger one as it is, okay? You can write the smaller one as it is also, and change the bigger one according to the smaller one. But right now, I'm writing the bigger one as it is, and I'll change the smaller one according to the bigger one, okay? So they have already given us angle P is equal to angle T. So the equal angles, I'll write it on top and on top. Angle P and T is equal. Now, is there any other angle that is equal? If you look properly, what in this also, they're sharing angle Q and angle Q, right? This triangle and this triangle. Similarly, in this also, they're sharing the same angle. Angle R and angle R. So R, we write it together. So done. T is written, R is written, S we need for a small triangle. So we have two angles equal. So by SS similarity, we can say that these two triangles are similar. So let's write in triangle RPQ and triangle RTS, we can say angle P equal to angle RTS, which is given, and angle R, oh, in this case also, the previous question, I forgot to write common. Okay, the reason. Angle R equal to angle R, which is common. Therefore, triangle RPQ is similar to triangle RTS. And a very important thing which students tend to forget is that I draw this, okay, so that I don't get the names mixed up, okay? See, when I write RPQ, I'm writing RPQ. That way, whenever you're writing the other triangle, you have to write it like that also. RTS. Okay, it literally means that angle R and angle R is same, angle P and angle T is same. And then angle Q and angle S will also be same, okay? So don't get mixed up there, because it's CBSE board, so NBSE teachers usually don't cut marks, but CBSE sometimes strict teachers comes. So that's it. We'll do number 6. Let's read the question first. In triangle ABE, or if triangle ABE is concurrent to ACD, let's see where is ABE. ABE is concurrent to ACD. So let's draw the triangles first in according to what they're saying concurrent. Okay, so they are saying ABE is concurrent to ACD. So concurrent means exactly the same, nah? ACD. It you have to see by the name. See, A is equal to A, C. So AB and AC will be same. Okay, so AB and AC is same. AE and AD is same, right? And then BE and DC will be same. Since it's concurrent, it's exactly the same. So even the measurements will be exactly the same, and the angles will also be same, obviously. So let's see. We have to prove ADE, the smaller one, and ABC, the larger one, to be similar. So we cannot use angle because in order to do angle, we have to show angle D is equal to angle B. But angle B, if you look closely, it's not complete. Even ABE, though arrow itu equal as the power 1, but we cannot show that this and this is equal. This one and this one, we cannot show that they are equal. There's no way to showing that because these things are not parallel also. So we cannot use that. Okay, so we'll have to use some other method. So we'll be using the sides. I think that will be better because it's concurrent, so all the sides are equal, right? So given triangle ABE is concurrent to triangle ACD. Therefore, we can assume, see, what we'll do is, since if I draw the big triangle, let's do it here. If I draw the big triangle and the small triangle, I can see that A, B, C, and A, D, E both share angle A, right? So if they both share angle A and we're supposed to use the sides of the two concurrent triangles as an advantage, what we can do is we can say that the ratios of this by this equal to this by this somehow, right? Got it or not? That's what we're trying to do. Okay, so we will need AE, AD, AC, AB. So here AE equal to AD, AE equal to AD we will need, and then we will also need AB equal to AC. This. That's what we're taking. Okay, so let's keep CPCT. Reason is concurrent parts of corresponding triangles. Corresponding parts of concurrent triangles, and let's make this equation 1. Okay, we'll use this later on. So let's start with the triangles. In triangle ADE and triangle ABC, we have AD by, let me show you the diagram. AD by AB will be equal to AE by AC. Why? From equation 1. Because AE and AD is same. So these two is same, AE and AD. And then AB and AC is same. So AB and AC is same. Which means AD by AB is exactly the same. AD by AB is exactly the same as AE by AC, because AE and AD is same and AB and AC is same. So this by this literally means this by this. Okay. And angle A equal to angle A common. I hope you understood the question. So therefore triangle ADE is similar to triangle ABC by what? SAS similarity. Done. Huh? Let's move on to question number 7. The question number 7 says altitudes AD and CE of triangle ABC. Let's see where the altitudes are. Altitudes means the 90 degree, okay? You always have to remember, even if they don't give you the box indicating that it's a 90 degree, you have to know that whenever they say altitude, it always is a 90 degree. So altitudes AD and CE of triangle ABC intersect each other at a point P. Show that the first Roman number 1 is AEP. Let's see where AEP is. A is here, E is here, P is here. And then CDP. C is here, D is here, P is here. So these two triangles, we can easily say whenever you see crossing of each other vertically opposite angles. So in triangle AEP and triangle CDP, angle APE equal to angle CPD, vertically opposite angles. And then they both have 90 degree. Altitude as itu 90, altitude as itu 90. So angle PDC equal to angle PEA, 90 degree each. Therefore triangle AEP is similar to triangle CDP by what? AA similarity, angle similarity. No? Acha, one thing, if any of you is like confused as to why I'm writing the full names and sometimes I'm writing the half names, nah? Like suppose in this case I wrote angle P, but in this case I'm writing RTS. It's because whenever you have a triangle, okay, and P is associated with only one angle, then you can write it as angle P. I can write it as angle Q, it does not matter. I can write it as angle R, doesn't matter. But you cannot use angle S or angle T, because angle T is not just this, it's also this. Okay, RTSP as a STQ, angle T to 3000. In this case also RST, okay, and then TSP. There's two angles, so you cannot use a single name whenever in this kind of situation. But if it's just P is associated with only one angle, so you can use angle P as angle P only. So in this case, I'm using the whole names because P is associated with about 4 angles. So, and then even here. Okay, so you have to use full names. Let's do the second one. Second one is triangle ABD. Let's check where ABD is. ABD. Okay, the big one. ABD is similar to CBE. Where is CBE? CBE. So they're literally saying this one and this one. So as you can see, when I do this one, we have a 90 degree over here, right? And then when I do this one, we have a 90 degree over here. So 90 degree is shared. Okay, so what other angle or side do we need? Since it has to do with angles, it is side like given there. So angle, so let's search for this other angle. So when I do this, we are including angle B, and when I do this also, we are including the same angle B. So that will be our common angle. So in triangle ABD and triangle CBE, angle, let's take the 90 degrees first, name ADB. ADB is equal to angle CEB, 90 degrees each. And then we can also say angle B is equal to angle B. And this time you can just write angle B because B is not associated with any angle. So common angle. Therefore, triangle ABD is similar to triangle CBE, that is AA similarity. Okay, let's do the last question. Round number 3. AEP is similar to ADB. AEP. Let's search AEP first. AEP, this small one. AEP and ADB. Where's ADB? ADB, this big one. So this small one and this big one. So right off the bat, we can see that this small one contains a 90 degree. This big one also contains a 90 degree. And when we do this, angle A is not changed. Angle A is still here. When I do here, angle A is still there. So we're going to take the 90 degree, and angle A and angle A. Same as this. In triangle AEP and triangle ADB, angle PEA equal to angle ADB. ADB is this, so PEA, which is 90 degree, equal to the 90 degree ADB. So ADB, and then angle A is equal to angle A. So this 90 degrees each. And then this is common angle. So triangle AEP is similar to ADB by A similarity. Roman number 4, you're gonna try it yourself. It's easy, it's very similar to this one. Okay. Now let's do question number 8. Last question for this video. E is a point on the side AD produced of a parallelogram ABCD. They have not given the diagram, so we'll have to draw the diagram. Let's draw the diagram ABCD first. Okay. Okay. Let's draw a parallelogram first. So ABCD. So they're saying E is a point on the side AD produced. So AD is produced extra. So let's produce it extra. And BE intersects CD. BE. So E is the produced of AD. Right? It is produced of parallelogram. E is a point on the side of AD produced of parallelogram. So AD is produced and E is the point. Nah? And then BE. So which means we have to join B and E also. BE intersects CD. CD at F. So it's intersecting this at point F. Show that triangle ABE is similar to CFB. So where is ABE? ABE, this one, and CFB, this one. So we have to show that this small triangle is similar to this big triangle. Okay. So since they're given in the question that it's a parallelogram, there has to be a hint, right? There has to be a hint. So in parallelogram, if you remember, if you recall from lower grades, the opposite angles are always equal. So this angle and this angle will be equal. So for this triangle and this triangle, we have got one angle already. We need one more angle. So one more angle will just, okay, let's do the first, this one there. In triangle ABE and triangle CFB, angle A equal to angle C. Okay. Opposite angles of parallelogram are equal. Is the reason? It is short form as a parallelogram. So opposite angles of parallelogram are equal. Now for the next angle, what I'm gonna do is I'm gonna take this. Okay, I'll just draw this. Okay, this same thing I'll draw it here. BC is here, AE is here. So if I draw this, which I've already told you in the last previous class, parallelogram means what? All the sides are parallel. So this is parallel to this and this is parallel to this. So which means this and this are parallel. And whenever there's a parallel line and you see a Z shape, this angle and this angle are called what? Alternate angles, right? Alternate angles. And alternate angles or alternative angles are always equal, right? So which means this is exactly a part of this only. So this and this will be equal since it's alternate angles. So we can write angle. We cannot write this thing. First we write this, okay? But since A, I wrote it here. A the tangwala so na, so tangwala E. Angle E is equal to angle. This I can write short name, but I cannot write this short name. I have to write the whole name. FBC. The reason is what? The reason is BC is parallel to AD, therefore alternate angles. Okay, therefore triangle ABE is similar to triangle CFB by what? AA, similarity. And that is it. Okay.